So, hey guys, welcome back. I hope you all are doing well and doing your studies also good. Many of your parents might have taken vaccination also up till now. Soon, you'll also get the vaccination, so you'll freely roam around. Schools are also hope so going to start. If at all it is starting, then well, wow, that will be the great time because online sessions make me also boring at times. But okay, so in this pandemic, we have learned a lot, right, to adjust with the situations and to do work from home. That is सबसे ज़्यादा important. Doing work from home is very difficult, but today also for me at least it is really very difficult. At homes we feel like sleepy, but still we have to do anyway. So we are doing the topic metals and non-metals in our foundation batch. So I hope up till now jitne bhi videos I have uploaded, you have studied them. So if you have doubt, please ask me without any hesitation. So you can ask any doubt regarding your subject. I'll be very happy to help you in that. So up till now, what we have seen, we were in enrichment of the ore, and we were doing the enrichment of ore or dressing of ore, you can say. Okay. In this we have already completed three types or three processes. Now we are supposed to do the fourth one. What three types we have seen? We have done our very first one, and that is the levigation, or you can say hydraulic washing. In that we actually wash the ore, right? Then the second one we have seen the froth flotation method. In that we use a small amount of oil, and in some places you'll find it is agitator for rotation, which will help the formation in of froth. And in some places, like in the earlier session I have told you, we blow air, okay, and from this air also there will be formation of froth or the scum. The scum or the froth will contain the impurities in it, okay. Then we have also seen the liquation. So liquation कहाँ पे यूज़ होता है? जहाँ पे जो melting point of the metal is very low, or not very but at least low with the in comparison with the your impurities, right? So impurities से low है, तो it can be easily used. So it can directly be heated, and when the metal melts it will float on the surface and will be easily removed out. Okay. So the fourth one which we are supposed to do now is your magnetic separation. Magnetic separation. Okay. So in magnetic separation, what we do? Basically, we have already seen these things. Okay. We use magnetic wheel. Okay. Why we use magnetic wheel? Basically, we use the magnetic property of the ore, because ore contain metal, and metals do have magnetic property, and since they have magnetic property they can be easily removed with help of a magnet. Okay. So we can just easily separate them from gang. Okay. So let's start with this. The very first point I'll write, and then we'll draw the diagram. Okay. I hope that's fine. Now magnetic separation में the first point is, it is used when the magnetic property of the ore of properties of is not visible, right? Of the ore, of the ore, and the impurities, are different, are different. Definitely when they are different, then only we'll be able to use this magnetic property, otherwise how could we? So for example, ठीक है, for example, there is a ore named tin stone. tin stone, it is ore of tin. ठीक है, tin का ore है tin stone. ठीक है, it contains wolfram as an impurity, that is magnetic. Wolfram is a magnetic impurity. To remove this impurity, the ore is basically powdered and make the magnetic ore, make the magnetic and non-magnetic particles distinct, or we can just separate them. ठीक है, the powdered tin stone is spread on a belt. ठीक है, it is a kind of conveyor belt. So while this belt moves, once this belt moves, same way में the electromagnetic property will make them separate. Them means the impurity wolfram and the metal tin or the ore tin. ठीक है, so moving over electromagnetic rollers. So basically what is an electromagnetic roller? A roller which is having a magnetic property. ठीक है, and then the wolfram being magnetic attracted, and the ore which is not magnetic will be separated. Clear? So let's see. So sometimes the ore may be magnetic and gangue may be non-magnetic, and sometimes ore may be non-magnetic and gangue may be magnetic. So let's see, we'll write the points over here and then we'll draw the diagram. ठीक है, so tin where we have seen कि contains ore of tin contains wolfram as an impurity. The ore is finely powdered. See, when we finally powder it, मतलब बहुत बारीक पाउडर करेंगे तो ओर और गैंग में ऑटोमेटिकली द पार्टिकल्स विल बी सेपरेटेड, सो विल बी एबल टू रिमूव देम विद हेल्प ऑफ मैग्नेटिक बेल्ट सेपरेशन. ठीक है, सो दैट इज़ वाई वी हैव पाउडर्ड देम. ठीक है, फाइनली पाउडर्ड, राइट, सो एज टू मेक देम डिस्टिंक्ट. ठीक है, सो एज टू सेपरेट magnetic and non-magnetic parts of the ore. ठीक है, now it is spread over a belt, right, which rotates on electromagnetic roller. Right, so now here in this case, that is the tin stone where wolfram is a impurity and is also magnetic, will be attracted and get collected in the pot near the magnet. ठीक है, whereas tin stone, that is the ore, falls away from the magnet. So we'll write here the same thing, that is the wolfram being magnetic is since it is magnetic, is attracted and gets collected in the pot near magnet. ठीक है, and whereas tin stone, that is the ore, falls away from the magnet. ठीक है, so this is what is exactly the happening in the magnetic separation. So we'll draw the diagram along with it. See, so basically we are taking a roller, electromagnetic roller. ठीक है, so this is a electromagnetic roller. ठीक है, and the conveyor belt is tied up here. ठीक है, and it will rotate on this only. ठीक है, so this is an electromagnetic roller. From here we basically pour the ore. ठीक है, now when the roller moves, definitely the ore will be coming with the conveyor belt till here. ठीक है, so the ore is coming to the end, so here it will come, and from here it will be segregated into two parts, that is one magnetic and other non-magnetic. So here, that is the pot near the magnetic roller, that is electromagnetic roller, will be filled with the impurity, that is wolfram, as it is magnetic in nature. Whereas in the container away from the magnet, there will be tin stone, that is the ore falling. So here you will get the ore, whereas here you will get the wolfram, that is impurity, right? So we'll write over here कि this is your ore plus impurity, ore plus impurity. ठीक है, then this is a magnetic roller, as I told you. ठीक है, this may be your ore. In some books you will find this as impurity and this as ore, so depend कि क्या magnetic property है उसके ऊपर. ठीक है, and this will be your impurity, but which kind of impurity? Magnetic. ठीक है, magnetic impurity. Clear? Okay, so this is what is actually the magnetic separation. So in the next part, or the next way for enrichment of ore is your leaching. So we'll just go through it, then your session तो end होगा ही, session के साथ enrichment of ore भी end हो जाएगा. Clear? Now the fifth type of enrichment can be done is known as leaching. ठीक है, leaching. This is obviously a chemical separation. ठीक है, so I can write here, or chemical separation. So we are using chemical technique, chemical reagents to separate the gang, right? So here you have to remember this, this is a chemical technique. So what happens, let's discuss first. See, what happens in this method, a powdered ore is treated. Whatever the ore is there, it is crushed, that is, it is finely powdered. Then this powdered ore is treated with a suitable solvent. What happens? Why we use this suitable solvent? Because this ore will dissolve in it, while the impurities will remain undissolved, and since the impurities will remain undissolved, they can be easily separated. For example, you can take in bauxite ore, it contains Fe2O3, then SiO2, etc. as the impurities. So we can easily remove, and Fe2O3 is not soluble in sodium hydroxide. So what we do, ore which is powdered will be treated with solution of sodium hydroxide, and when sodium hydroxide is added to bauxite ore, it will dissolve Al2O3 and SiO2 present in it, right, forming what, forming sodium aluminate. Okay, so when this Al2O3 and SiO2 dissolves, it forms a chemical with sodium hydroxide, that is sodium aluminate, and sodium silicate respectively. The impurities will be left behind, and since the impurities is left behind, it can be easily filtered out. Now the filtrate containing sodium aluminate and sodium silicate is stirred, continuously stirred. Why? When we basically stir it, some freshly prepared aluminum hydroxide for with some we add actually aluminum hydroxide for several hours, freshly prepared aluminum hydroxide. So while stirring, okay, then sodium aluminate undergoes hydrolysis and produces the aluminum hydroxide as precipitate. Now we get aluminum hydroxide as a precipitate, okay, which can easily be removed. Then sodium silicate is soluble, remains in the solution. We don't want silicate, right? So we leave it, and the precipitate is basically filtered out, washed, dried, and ignited, gives pure Al2O3. That's it. By heating, we get pure Al2O3. So this is all we have to write in stepwise manner. Okay? So basically what it is. So leaching ka definition will write here. Powdered ore is treated with the suitable solvent, with the suitable solvent. Okay? So when we add a suitable solvent to it, the ore will dissolve. Ore dissolves, leaving behind impurities. Okay? So impurities can be easily removed, that is filtered out. So let's also see the reaction to it. So let's take example of aluminum itself. So for example, we are taking bauxite. Okay? Bauxite ore contains Fe2O3 and SiO2 as impurities. So you have to remember that this is impurity. So just these impurities can be easily removed, right? So what we do, the first step in this powdered bauxite ore is treated with, or dissolved, is dissolved in the solution of sodium hydroxide. Okay? Now Al2O3 and SiO2 in bauxite gets dissolved dissolved in it, forming sodium aluminate and sodium silicate. See, silicate is also an impurity, so we need to remove this also, na? Silicate. While Fe2O3 remains undissolved. ठीक है? While rest of the impurities remain undissolved. ठीक है? Now this undissolved impurities can be easily filtered out, which can be easily filtered out. Now this dissolved substance, to this also what we add a small amount of aluminium hydroxide. So now adding small amount of, right, we are basically not doing anything, but we are adding small amount of aluminium hydroxide, right? In the container with sodium aluminate and sodium silicate. So जहाँ पे सोडियम एल्यूमिनेट और सिलिकेट है उसके साथ हमने इसे मिक्स कर दिया, ठीक है, एंड स्टिरिंग, continuous stirring is done. Continuous stirring is done. ठीक है, so we are continuously stirring it. So now when we stir it, then the obviously there will be formation of aluminium hydroxide. ठीक है, now what will happen after several hours? For several hours we are keeping it, stirred, right? So sodium aluminate undergoes hydrolysis, right? Sodium aluminate undergoes hydrolysis, and when the hydrolysis will occur, obviously there will be formation of aluminium hydroxide, right? So we'll write here that hydrolysis, right? So hydrolysis and aluminium hydroxide is formed. ठीक है, see, the small amount of this aluminium hydroxide which we have added over here, na, it will just boost the reaction. It is a kind of catalyst, you can say. ठीक है, now this soluble sodium silicate will remain in the solution, whereas there will be aluminium oxide which will be precipitated out. ठीक है, sorry, aluminium hydroxide which will be precipitated out and filtered, washed, dried and ignited gives pure alumina. ठीक है, so we will just do this. So what we'll say? We'll say sodium silicate remain in the solution whereas aluminium hydroxide will precipitate out. Now due to this precipitation, it is easy to separate, right? Which can be filtered out. Filtered out, then washed, dried, and then ignite karo, you get pure alumina. So we'll write the reactions. See, we have Al2O3. This combines with the sodium hydroxide. Okay, but along with this there is aluminum silicate also, right? Okay, now it will form NaAlO2, that is your sodium silicate, and water. Okay, now this sodium silicate, sodium aluminate, this sodium aluminate will be hydrolyzed by the water, forming aluminum hydroxide. Okay, and sodium hydroxide, which will be separated. Now this is a precipitate, so since it is a precipitate, it will settle down, and after igniting, heating, etc., we get pure alumina without silicates, without anything. Okay, so we get Al2O3 plus 3H2O. So all these things are done. So leaching is a process, is a chemical process, definitely, as we have studied, कि इसमें आपको सारा जो chemicals है, they are added, basically a solvent is added in which the ore is dissolving and the impurity is unable to dissolve. So then we can easily separate the impurity and the ore. So these are the different methods of enrichment of ore which can be used and implemented. Okay, so we have seen all the 5 methods which were there in the book. Leaching is an extra I have given. There were only 4, so we have done all of them. So with this, I hope you all are able to understand what we have done. So we'll just complete the session with this, and we'll meet in the next session. Till then, bye bye.